What is up, CTM students? Welcome to the lesson on 4.4. It can be found on these pages here. These are not necessarily vocabulary, but things we need to know how to do by the end of this lesson. So we are going to be adding, subtracting, multiplying, and dividing in other bases. Just to kind of recap where we've been so far. So in 4.1 in this chapter, we learned about these different systems, and we had different ways of writing down numbers, numerals, different forms of that. In 4.2, we saw some other forms, the Babylonian and Mayan systems, where we had actually different bases now. So some things like this, where they had base 60 essentially, the Babylonians, and for the Mayans, they had what was a base 20 system with that weird 18 thrown in there. And so we're kind of building on that as we continue here. In this lesson, we had different bases, other bases, other than base 10 like we have, base 60 like the Babylonians, base base 20 with that weird 18 with the Mayans. So we have these different bases. We had any basic number that we could think of that could be our possible base, so base 9. So now we are going to be doing addition, subtraction, multiplication, and division in these other bases. So let's get moving on here. Definitely be using these extra examples in your book. I'm going to show you what I think is the easiest way, or the most simplest way to explain things, but the book kind of goes more a little in depth with certain other methods or certain other ways, or just kind of more in depth with the way we're doing things as well, explaining some extra things there. So let's get started on example 1. That is not example 1. I don't know what that is. Let's anyways move on to okay, now title this in your notes, 4.4 notes, computation in other bases. Let's give a heading up towards the top here. This is going to be addition. So we're going to have 4 different headings like this. We're going to start off with addition. So let's now check out, there we go. Now let's check out example 1 here a second. So let's start off with this. We're going to say, I'm going to leave a little bit of space up here because I may want to write some stuff up here, and definitely a decent amount of space down here. So let's write this down first of all that we have, and I'm going to space my numbers out a fair amount as well, but 2, 3, 4, 1, and remember, if I write a little subscript, that means that's the base. So 2, 3, 4, 1, base 6, and also 4, 2, 3 in base 6. I'm going to be adding these two things together. Alright, so let's see, how can I do something like this? And if you have something you can lightly draw in some lines here, you could use pencil for that. I'm going to use yellow for this here. I'm going to lightly draw in some vertical lines to help me just keep things straight. I want yellow, not black there. This is kind of like we had with our logic tables, just helping us to keep our columns in order as we go down here. Okay, so I think that's going to be helpful if you lightly draw in some extra lines in here as we go. So we're used to doing this. If this was just base 10, we would just say, oh, that's a 4, that's a 6, that's a 7, and that's a 2, and we'd be done. But base 6, other bases, it's a little different. Remember, this would be 4 and 6 because this is the ones place, this is the tens place. But in base 6, this is the ones place, this is the sixes place, and this is the 6 squareds place, and this is the 6 cubes place. So we have to think of this a little differently here. So let's just start off by adding the 1 and the 3, and we're going to be thinking about stuff in base 10 first, and then converting back to the base here if necessary. 1 plus 3, that's just 4. Is 4 a number, a digit that's allowed in base 6? Sure. So this I can write just as a plain old 4, and let me use the black for that. Back to black. Alright, so I have a 4 here. Nothing really necessary to do there to change that. Down here, if you have a different color, not if, let me rephrase that. You need to get a different color here. So I need to see, in your notes, I need to see some different colors when we are doing stuff in base 10, because I want this to stand out from what we're doing up here. So if you need to, stop right now, go get a different color, come back, pause the video, come back, get that, have that different color ready to go to use here with what we're doing. So now you've got your different color. This, I'm going to write stuff down here this is base 10 stuff. So anything I'm doing in orange in this whole lesson, I'm going to say goes with base 10 things. So it's kind of like my intermediate steps that I need to do to be able to get what that number is up here. So this was just 4. Okay, let's think of this now. 4 plus 2 in base 10, that would be a 6. But is 6 a digit that's allowed in base 6? No, you can only have 0 through 5. So if you wrote a 6 down here and you said that that was a digit that's allowed in base 6, you would not be correct. What do we do? Alright, so for right now, I'm going to kind of show you the things that are going on, the steps that are going on in my head. So this right here is what we would be doing. We take 6 and we're saying how many groups of 6 go into 6. In other words, what's 6 divided by 6? That is 1 with a remainder of nothing, with a remainder of 0. So I want you to think of it like this. As we move on, we're not going to be writing this part, but for right now, with these first few examples, we are going to be writing this down. So what does that mean? What do I have here? Well, I have 1 with a remainder of 0. So my remainder, that goes right here. That's what I'm left over with. I have one group of 6 based on what I have here added together. That 1 is going to be carried over into the next place value. So this is 1 with a remainder of 0. That same sort of approach, same sort of tactic will work with all these kinds of problems that we're doing. So 1 with a remainder of 0. We have 1 with a remainder of 0. What do we have here? Let's go back to orange now, thinking again in base 10. 1 plus 3 plus 4, that would be 8. Okay, so can we write an 8 down here? Is 8 allowed in base 6? No, just 0 through 5. So I need to take this and think of it as a number in base 6. How do I do that? Well, you're saying how many groups of 6 go into 8? In other words, what's 8 divided by 6? Well, that's 1 with a remainder. There's going to be 2 left over when you do that. 1 with a remainder of 2. So what goes here and what goes here? It's the same sort of thing. 1 with a remainder of 0. Just like that. So I'm going to have 1 up here with a remainder of 2 down here. A 2 goes in right there. And now I can do my last column. 1 plus 2. That's 3. 3 is an allowed digit right there. I should have brought my orange out there, 2 there. So 3, but that's allowed in base 6, so a 3 is okay up there. So what's my final answer here? If I'm adding this plus this, I get this. So this is my final answer, 3204. That's what these two numbers are in base 6 added together, still in base 6. So again, I want to remind you, this was base 10 work. This was necessary to get the numbers here. The method I'm using at least, I think this is, in my opinion, I think this is the easiest way to do these kinds of problems. But just be conscious of the fact that we're having to go back into base 6, or whatever this little subscript number is over here. So is this going to be initially looking kind of weird, like what is going on? Yeah, I think so. It was that way for me to start too, when I never had done anything like this before. It took a little while to wrap my mind around it, but I feel like I have a really good understanding of it now, and so I'm going to try to explain it in as simple of terms as I possibly can. I hope that it will make it easy for you to understand as well. So let's again write down some numbers, leave some space. This one's going to be in base 2 though, so I can only use zeros and 1. So 1, 1, 0, 1. This is base 2, a little subscript 2. And I'm going to say the other one is a 1, 1, 1, base 2. This one actually is an example of your book. Most of the time I try to do different examples from what's in the book, but the book has a different method for this one, so I'm going to show you my method, or the method that I think is easier. The book gets into that method too, but they show kind of a different method for this one. So you can look in your book to see a different way to do this one. And I think you'll agree with me if you look at that what I'm doing here is a lot easier way to think about it, as long as you can do a little bit of mental math with it. Okay, so let's make some columns. And again, I'm going to go down here and say that I'm considering things down here in base 10. That's still in yellow, sorry about that. So my orange stuff, there we go, my orange stuff is base 10 stuff. So down here, let's think in base 10, more what we're used to. So let's start adding my columns. So just the same way, moving left to moving right to left as we add our columns here. 1 plus 1 in base 10 is 2. Is 2 allowed as a digit in base 2? No. It's just 0 and 1. So what do we have to do with this? We have to take this and think of how many groups of 2 go into 2. So 2 divided by 2, what's that? That is 1 with a remainder of 0 again. So this one, same sort of idea as I had over here. I had 6 divided by 6, 1 with a remainder of 0. So I put a 1 up here, carried a 1, wrote down a 0. My remainder is what I write down, the other one's what I bring over. So let's do the same thing here. I'm going to be writing down a 0, that's my remainder, carrying the 1. Alright, let's add this next. Go back to orange, back to thinking in base 10. 1 plus 0 plus 1 is 2 in base 10. And then this, what do I got to do? Well, the same thing. So I'm just going to reconnect it to there. I won't rewrite that down. So again, I have to carry a 1 and write down a 0. Alright, now what do we got? I got 1 plus 1 plus 1. Base 10, that's 3. So this one, how many groups of 2 go into 3? 3 divided by 2 is 1, with a remainder now of 1 instead of 0. There's 1 left over. And so what do I write down up here? I would have 3 divided by 2. We got 1 remainder of 1, so a 1 goes here, and I put a 1 there. And then, looks like I got my last thing here is 1 plus 1 again, so that's another 2. So again, I will just reconnect this over here. And what am I going to put down there? Well, I would put a 0 with a remainder of 1. Now my remainder of 1 could go up here, but there's nothing to add it to, so I'm just going to add that 1 at the very end. So this becomes 10100 in binary code. What I started with added together gives me this. Alright. So far we've only been adding 2 different numbers together basically. We got 1 plus another is that. Have we ever added more than 2 numbers together in base 10? Sure, I sure hope you have. So let's do one where we have, actually we're going to add 4 different numbers together. So let's use, this time I'm going to use base 5, leave a little bit of space here. Make sure you're numbering your examples for me as well. So example 3, let's put that down. And let's write down what we got. So leave some space here, kind of write things wide. So 414 base 5, 203 base 5. Keep them lined up nice and straight for me. 144 base 5. Again, these 5s are smaller, they're subscripts, they should be written kind of underneath or at the very bottom here. And 433 base 5. You should notice something about all these digits here, they're all less than 5. That has to be true since we're working in base 5. So I'm going to put a plus sign here. I'm going to add all these together. So let's do the same sort of thing I've been doing so far. I'm going to add these vertical columns. I'm going to take this like this, add another column here, and then down here I'm going to have what I'm doing in base 10. So let's write base 10 again. Anything in orange, you're putting in a different color on your notes if you want full credit for these notes. Got to see that happening. Alright, so base 10 stuff, this is all down here. Let's do this thinking first in base 10. So what's 4 plus 3 plus 4 plus 3? That'd be 7 plus 7, which is 14. So I'm going to write a 14 down here. So what is 14? Am I just writing a 4 and carrying the 1? If it was base 10, yes, but that's not what I have here. I have base 5. So what do I need to think of? And this will be the last time I write something like this down. If you want to keep writing things like this down, if that helps you, feel totally free to do that. But I'm going to be doing this sort of thing mentally from here on out. But 14 divided by 5, how many groups of 5 go into 14? Well, that's 2 whole groups with a remainder of 4. So this becomes 2 with a remainder of 4. So what's going to go up here? Up here I'm going to have, well, the remainder goes down here. So I got a 4. 4 is allowed. That's something less than 5. And the 2 is going to go up here. 2 with a remainder of 4. So we got that first column out of the way. Now let's think about this one. 2 plus 1 is 3, 3 plus 4 is 7, 7 plus 3 is 10. So I'm going to write a 10 down here. And again, let's think of this in this way. So how many groups of 5 go into 10? That's going to be 2 with a remainder of 0. So hopefully we're starting to catch on to this. What goes here? We got a 0. And what goes up here? We got a 2. 2 with the remainder of 0. And finally, let's add these together. 2 plus 4, we got 6, and then 8, 9, and 13. So down here, I'm going to write a 13. What is 13 divided by 5? 13 divided by 5, you have 2 whole 5s with a remainder of 3. So 3 left over. So what goes in here? Well, down here, I had my remainder. I would have my remainder of 3. And then you would carry the 2, but there's nothing else to add it to, so we just rewrite down the 2 or write it down right there. So this all becomes what you see here. This is my final answer. 2304 base 5. So with these, they might take a little while to catch on. Feel free to look in your book for extra examples, as always. Also feel free to try some of those odd ones that might not get assigned. And you can check those in the back of the book to see if you're catching on, if you're doing it right. So let's move on to the, what the heck, that's the same thing, isn't it? What is this coming from? That's just a little bigger this time. I really don't know what's going on. Anyway, subtraction. So subtraction, what do we do to subtract things in different bases? How do we handle something like that? So here's an example that deals with subtraction. So again, leave a little bit of space up here. We'll need to do a little bit of work up here, but I'm going to write down this. Again, leave things kind of wide. Give it a wide range here across the page. So there's 6, 0, 4, 5, and this time I'm going to go base 7. And I'm going to say this minus 2, 0, 2, 6. We have this base 7. And so I'm going to get a number here, base 7. If this was base 10, I would borrow from here. I'd have a 3, and then I'd call this a 15. And then I would work it out from there. I'd have a 9, a 1, a 0, and a 4. It's essentially the same sort of idea, except if we're going to borrow, if we had base 10, we're borrowing a 10 from over here and putting that here. But now this is base 7, so instead of borrowing a 10 from the next place, we can borrow 7 from the next place. Or if this was 12, we could borrow 12 from the next place. If this was just 2, we could only borrow 2 from the next place. So let's start working this out. Let's put our lines in here. Do that lightly to help us. Nope, it's orange. Let's use yellow there for me. So keeping this coming straight down, keeping this coming straight down. And you know what, I really, looking at this again, for subtraction I don't really need the lines, so I'm going to erase those. Sorry if you drew those in there, but I really don't need the lines for subtraction. I think subtraction might even be the easiest of the 4 that we're doing here. So let's check this out. So let's think about what I was saying there. So this is base 7. If I'm going to borrow from this next place, which I have to do here, 5 minus 6, that doesn't work. So I need to borrow from here. So I'm going to cross this out. And it's black there, so I'm going to cross this out, and this would become a 3. So I still have 1 that I'm borrowing from here, but if I'm going to borrow here, this, I'm borrowing 7. So what's 7 plus 5? Now we consider this kind of adding in base 10. What's 7 plus 5? That's going to be a 12. And then 12 minus 6. Now that's something I can do, and 12 minus 6 is just 6. And is 6 allowed? Is that a digit allowed in base 7? Yep. That's good. So as long as it's less than 7, it is allowed. Now I can do 3 minus 2. That's just 1. That's allowed in base 7. 0 minus 0, still 0. And then 6 minus 2, that's a 4. So this one, I would say 4016. That's what that equals in base 7. Let's make a little note here, and we are going to do a check with each one of these, though. So if borrowing, write this note down off to the side. Very important to note this with subtraction. So you must borrow a group of 7. Let me write the 7 up there with that. A group of 7. I'll underline this here. So if you're borrowing, you must borrow a group of 7 in base 7. That's what we're dealing with here. So if you're borrowing the base of 7, you got to borrow a group of 7 from the next one. You can add that to this. Just like if this was base 10, I would be borrowing 10 from here. This would become a 3, and then I would add 10 to 5 and get 15. But here I'm borrowing 7, so I'm adding 7 to 5 and getting 12. So if borrowing, you must borrow a group of 7 in base 7. And then let's do a little check here. So this check, I'll do this in green, because if it's good, then we're good to go, like a green stoplight. Or a green light at a stoplight, maybe I could say. So a check. Let's check and see if this works out. How can I check my answer with something like this? I just need to add these two numbers together. If I take this plus this, it should give me what I had on the top there. So let's see if that works out. So we're going to have 4, 0, 1, 6. This is that base 7, and I would add 2, 0, 2, 6. And see what I get. Okay, so now I'm going to use my yellow lines again. Alright, bring that down, bring this down, and bring this down. Down here, let's do stuff in base 7, or base 10, excuse me, base 10 down here. And let's add, oh, there we go. Add a little 7 here, so this is base 7 as well. Let's add what we got here. This is going to be a 12. Okay, so do I put a 12 here? No, I can't put a 12 there. But how many groups of, and again, I'm not going to do what I was doing here anymore. I said I was leaving that out. So this I'm going to do in my head. If you're more comfortable writing it down, you can write it down. But I'm going to do 12 divided by 7 in my head. 12 divided by 7 would be 1 whole. So the 1 whole would go up here with a remainder of 5. So that would go down there. And now what's this become? Well, 1 plus 1 plus 2, that's 4. So no need to change that. That's already good to go in base 7. So this would be a 4. And then 0 plus 0, looks like that's good to go as well. So I'd have a 0 here. This would become a 0. And 4 plus 2 is a 6. So both of those are good to go in base 7 already. So I have this and this. Notice I didn't really look up here because I didn't want to skew my thinking. But did I get what I was supposed to get? Did I get what I started with? Let me circle that instead of box that in. So this isn't my final answer. This is just my check here. So does this check out? I would definitely say yes. I'll put a little check mark there. That is good. That checked out. For the next two, I'm not going to do the check. I'll leave that to you if you want to do the check just to verify that it's right. If you're doing a quiz or a test or something like that and you don't take the time to check when you have the time, and if a quiz or a test is worth a lot of your grade, it really doesn't make sense to me. If you can check your answer and know that you got it right, why not do it? Why not check your answer? Take a little bit of extra time. Make sure you got it right for what really, really counts for your grade. You might as well be using that time wisely and checking your answers whenever possible. I always did that back when I was in school, and always checking my answers whenever I could to make sure that I did it right. Sometimes I would catch mistakes, and often I got better grades on my tests because I would check my answers. So let's do another example with subtraction. We got 9, 5, 7. This is going to be base 12 now. Okay, so dealing with a bigger base than base 10. And this minus 2, remember I can have a T and an E in base 12. T stands for 10, E stands for 11. So I'm going to say 2, T, and 9 in base 12. And let's see what I got here. So this base 12, I'm going to write this a little more succinctly than I did here. So if you're going to borrow in base 12, you got to borrow how much? You got to borrow 12 instead of 10 like we're used to. So we're going to borrow 12 in base 12. If we need to. Do we need to here? So 7 minus 9, yes, I need to borrow from over here. So I need to borrow, I'm going to reduce this by 1. But what did I just borrow? I borrowed a group of 12 here, not a group of 10. I borrowed a group of 12. So what does this become? 7 plus 12, thinking of it right now in base 10, is going to be 19. So 19 minus 9, is that possible to do? Yes. What is that? That is 10. Do I write 1, 0? No, that's not a digit, not a single digit, but remember I have t as an option in base 12. So t stands for 10 in base 12. So this becomes just plain old t here. Alright, so that's all set there. Now I have 4 minus 10 is what that says. 4 minus 10, that doesn't work, so I'm going to have to borrow again from over here. Make that one lower. I just, careful here, the comment, I'm going to do a mistake. See if you catch my mistake. Did you catch my mistake there? What was my mistake? This, I borrowed 12, but then I just added 10 here. That's base 12, not base 10, so I can't do that. So I had a 4 there. Let me undo that last step. And what should I be adding? So this was a 4. I should be adding to the 4, I should be adding a 12. So this 4 is going to become 16 instead. What's 16 minus 10? 16 minus 10 is 6. Okay, so this column is taken care of. 8 minus 2, that is 6 as well. No need to borrow on that one, so this would be my final answer. 6t in base 12. Could you check this? Absolutely. Should you check this if you are doing a quiz or a test, something big, something worth bigger points for sure? Should you check it in the back if you have answers in the back of the book? If it's an odd one, absolutely. Should you even check it on your homework if you can? Yeah, I would definitely do that too. But for right now, I'll just tell you that I already checked this one and it did work out. So I've done that before doing the notes here. I checked and made sure that these all checked out. So let's do one more subtraction example. And let's go back to base 2 now. So sometimes base 2 looks the weirdest. At least it does to me sometimes. But just because you've only got all these zeros and ones, it just seems at first glance it's like, what's going on there? But we think of it the same way. So let's say it's 1010 base 2 minus 111 base 2. So now we got base 2. What are we going to borrow? If we need to, we're going to borrow 2. Not borrow 10. Base 2, you're going to borrow 2 if necessary. So do I need to borrow here? Yes. 0 minus 1, that doesn't work. So I need to borrow here. This is going to become a 0. And I'm going to make a mistake here again. What was my mistake? Did you catch the mistake? Can't do that. You just put 10 here. You can only borrow 2 in base 2. So that, let's see, let's undo that. This should become 0 plus 2 is 2. Okay, so 2 minus 1 is 1. Do I have to borrow again here? Yes, I do. So can I borrow from here? I can't borrow from there, so I got to go one more place. Okay, so this is going to become a 0. And I just borrowed 2 here, so this would become a 2. I added 2 there. Now can I borrow from there? Can I take one of these? Yeah, and I can put that here. So I'm going to add 2 here now. So I borrowed from here, gave a little bit to here. I borrowed from here to give a little bit more to here. So I have 2 minus 1 being a 1. Now I have 1 minus 1 here. That's just a 0, so I don't have to write down a 0 because there's nothing left. There's a 0 here, there's a 0 here. Those I can leave off. So this minus this in base 2 is just a 1 and a 1. Could you verify your answer here? Yes. So you could check this. You could say 1 plus 1 would give you the 10 in a sense. You got a one group of 2, so you'd have a 0 and that. You could keep going with that idea. I'll just tell you again that I checked this one. It did work out. But I would highly recommend that you try checking it on your own and see that it does work out. Verify that this plus this does actually get you that. I've already verified that. To save us a little bit of time here on the video, I won't show you that. So it is time to move on to our next one, multiplication. Oh my gosh, what is that? I don't even know. But multiplication. Alright, so multiplying in different bases. we're going to do a couple examples of multiplication. So I think now that you're learning a little bit more how different bases work, leave a little bit of space up here, but now that you're learning that a little bit more, hopefully catching on to it a little bit more, we'll just do a couple here instead of 3. We'll do 2 instead of 3. So 34 base 8 times 6 base 8. What is that going to give you? So I'm going to go back to my columns here, adding in some, for you, adding in some light lines to help differentiate what's what. So this is going to be down here. This is going to be base 10 stuff again. So base 10. That work coming down here. And what do I have to start? So if this were base 10, I would just take 4 times 6, put a 4 because it's 24, carry the 2. Same sort of idea, but we have to think in base 8 now though. So 4 times 6, first thinking about it in base 10 is a 24. You could circle this and divide 24 by 8, but you can also think of it this way. So I'm going to do this mentally, but be careful if you're not as good of doing that mentally as I'm able to right here. Maybe you want to write that down. Maybe you want to write down 24 divided by 8 would be 3 with a remainder of 0. So I just did that, thinking of that in my head. 3 with a remainder of 0. What goes here? The remainder goes there, 0, and you carry the 3. So you had 3 groups of 8, in other words, in base 8 with the 24. So 3 with a remainder of 0. Now what's 3 times 6 plus 3? Doing this, our thinking right now in base 10, that would be 21. Okay, so let's think about this. Again, if you want to write this down, you can. But what's 21 divided by 8? Well, I know there's 2 groups of 21 in 8, and I would have 5 left over. That would be 2 with a remainder of 5. So a remainder of 5 right there, and then a 2. I would put that over here, but there's nothing else to combine it with, so I can just write down the 2 right there, and then this would be it. 250 base 8. So 34 in a sense times 6 would be 250 in a sense base 8. So 34 times 6, 250 base 8 right there. Moving on to example 8, our last multiplication example, and then we'll tackle division to end it up here. So let's say we had something like this. Let's make it a little bit tougher here. We're going to say 3, 1, 2. We're going to say this is base 4. So no digits allowed that are 4 or more. And we're going to say this times, now I'm going to have 2 places for this next line. Before I just had 1, so I really only needed to do 1 line. If we're thinking in base 10, let's think about it in base 10 first. So let's add some yellow lines in here. This one I'm going to make a bit longer because I'm going to need to add some extra rows in here. I think that should be good. Okay, and now let's think again down here in base 10. So I know I'm going to have this first row, and then I have to kind of put an X or a 0 there, or just leave it blank and do the second row, and then add those 2 things together. I'm used to doing that with longhand multiplication in base 10. It doesn't change in base 4, so I'm going to have 1 row here, 1 row here, and then my final row, my final answer there in a sense. And so I'm going to just I'm going to kind of just do a little something like this. I'm going to say this stuff down here is base 10. So this should leave me enough room, kind of just draw a line lightly across where you definitely have enough space to put in 3 more rows up here. And so we'll do the 3 rows in base 10 thought down here. So let's see what we got. 2 times 3, that would be 6 base 10. So I'm going to put a 6. Is 6 an allowed digit in base 4? No, it's not. So what would I write instead? How many 4s go into 6 and how much is left over? There's 1 whole 4 goes into 6. That goes here, 1 group of 4 with 2 left over. 1 with a remainder of 2. So keep moving on, that same thought process from here. So I have 2 times 3 is 6, but that becomes 1 with a remainder of 2 here in base 4. What's 1 times 3? That's 3 plus 1 is 4. So in base 10, that's my thought. Is 4 allowed in base 4? Nope, that's too high. So how many whole groups of 4 do I have in base 4. 4 divided by 4 is 1. That goes here with a remainder of 0. So that goes there. Keep that thought process going. 3 times 3. That's 9 in base 10. 9 plus 1 would be 10 in base 10. So here I would have 10. How many whole 4s go into 10? There's 2 whole 4s with 2 left over. So the remainder is a 2, and then there's no more places to add it to here. So I would have 2, remainder of 2 like that. And then from here it kind of depends what you've learned. I sometimes would say leave it blank or write a 0 or write an X. I'll put an X here just to let us know that that spot you have to move a place over when you start with this next place value. I'm going to cross off all of these as well. So I dealt with those. Don't erase them. I need to see those. I need to see that you knew how to do that first line. But then from here, let's work it out. So this one, let's put an X here as well. Thinking about it first in base 10. What's 2 times 2? That would be 4. Does 4 go here? Is that allowed? No. So what do I put there instead? How many whole groups of 4? That's 1 whole group of 4, so I'm going to carry a 1, and my remainder is 0. So that goes here. 1 with the remainder is 0. So I took care of that. Now I've got to take care of this. 1 times 2 plus 1. 1 times 2 is 2, plus 1 is 3. So that's what would go next here. Is 3 allowed? That's allowed. So this one I don't have to change. I don't have to convert to base 4. I can just put a 3 right there. And then finally 3 times 2. That is 6. So this one I'm going to add an extra column here in my yellow just to keep things straight. That's not quite far enough over there. Let's try, there we go, that looks better. So add an extra column. Let's do that on your notes too. And let's see what we got here. So in orange, I said 3 times 2, that's going to be 6. So over here I'd have a 6. 6 is not allowed, but 6 is 2 with a remainder of 2. So I would put my remainder of 2 here, and I would have a 2 after that. So if I add all this together now, first I should think of it in base 10, adding what I have, not adding what I have down here, but let's think of what I have here going in base 10. So this, I'm kind of done with this. I'm not going to cross it off, but I'm done with this. I'm not adding what I see here. I'm adding what I see here. 2 plus nothing is going to be a 2. 0 plus 0 is going to be a 0. So those things I can write down right away. There's no need to change, convert into base 4 with those. They're already good to go. 2 plus 3, that's going to be a 5. Notice I'm not doing this plus this. I'm saying what up here. Base 10, just each individual line. 2 plus 3 is 5. 5 doesn't work up here. Not working right there. It's not a number, a digit that's allowed in base 4. What is this going to be? There's 1 whole 4 in 5 with 1 left over. 1 with a remainder of 1. And so this next line, I get the same thing. I get another 5. And so I'm going to have the same thing here, 1 with a remainder of 1. Looks like I'm going to add one more yellow line here just to keep my stuff straight. And so from here, what do I have left? I've got what's 1 plus 2, that would just be 3. No need to convert a 3 there. And so I would have 3 right here. So this whole thing, this is my final answer here. 3, 1, 1, 0, 2, base 4. So remember, if it helps you, if you find this helpful, you could say, you could keep doing what we were doing before. Don't write this down right now, only if you find it helpful and you want to do that with all these. But remember, we can say this is 6 divided by your base is 4. That was 2 with a remainder of 2. So if you find that helpful, please do something like that. If you find that helpful, kind of connect the things. So that would became the 2 right here with a remainder of 2 there. And that's why I check what I say. 2 remainder 2. Come on, Mr. Wagner. You did it right up here. So not 2 remainder 2. That's 1 remainder 2. There we go. So if you're doing this, 1 remainder of 2. But again, do you have to write this stuff down? If you're doing it mentally, no. So I'm going to erase what I just did there. But if that helps you, you can do that with every number that's, in this case, 4 or bigger, because 4 is your base. But this, I'm going to get rid of that. That is not something that you have to do from here on out. It's only if that is helpful for you. And there we go. I could have made my eraser bigger, but that worked. Alright, so let's move on to now division, our last of the 4 concepts. And it's still there. What does that even, what does that say? I can't hardly read that. Anyway, division. How do we do division, long division, in different bases? So let's see what I've got here. I'm going to have, I'm using black, nope, it's on orange still, there we go. So let's say I want to divide, that's kind of an ugly divided by symbol. Let's make that a little prettier. So I want to divide 4 to leave some wide space here so we can think about stuff. I'm going to use some yellow lines again, so we're going to kind of carry down our lines here. 4230 base 5 divided by 3 in base 5. Do I need to see these little 5s here? Yes, otherwise I'm assuming they're base 10, so that's a totally different problem. So this is 4230 base 5 divided by 3 base 5. What do we need to do first with something like this? So this kind of goes back, harkens back to things we had been talking about in previous lessons. We have to know about the multiples of what we have here. So I'm going to say, in this case, it's the multiple of the divisor. The multiple of, in any case for long division, the multiples of the divisor. What's the multiples of 3 base 5? What are those? So down here, let's write those out. I have 3 base 5 times the first thing. I don't need to do 0 because 0 would just give me 0, but times 1 base 5. Think of it in base 10 first. So over here, same sort of thing. I'm going to make a line here, and I want to think about first in base 10, what would we have? And then convert that over back to base 5. So 3 times 1, that's just 3 in base 10. And is 3 allowed in base 5? Yes, it is. So this would just be 3 in base 5. Something times 1 times the identity is always itself. So that's not going to change. So what's now 3 base 5 times 2 base 5? What's 3 times 2 in base 10? That would be 6. Is 6 allowed in base 5? No. So what is this going to become? There is, how many 5s go into 6? There's 1 with 1 left over. So I would have my remainder of 1 would be my first place, and then there was 1 group of 5 that went into 6. If you work this out, it would be 1 with a remainder of 1. So I have 1 with a remainder of 1 right here. 3 times 2 is 11 in a sense in base 3, but we would just say a 1 and a 1. 3 base 5 times 3 base 5. That's the next one. And so what's 3 times 3 in base 10? You would say that's 9. So over here, I'm going to write a 9. Is 9 allowed in base 5? No, that's much too big. So 9, how many whole 5s go into 9? There would be 1 whole 5 that goes into 9, with how much left over? There would be 4 left over. 1 with a remainder of 4, in other words. So we have 1 and a 4 base 5. What's 3 base 5 times 4 base 5? This would be 3 times 4 in base 10 would be 12. How many whole 5s go into 12? There are 2 whole 5s that go into 12 with a remainder of 2. So this would be 2 remainder 2 base 5. If I did 3 base 5 times 5 base 5, 5 is not allowed. So this is as far as I can go. These are the 4 multiples, non-zero multiples of 3 base 5. So I'm going to use these right here. Let's circle those. These are the most important numbers from over here. Okay, so over here, I'm going to be looking at this list. This is a very important list of numbers. When we're doing problems like this, we have to write out this list of multiples first to be able to do long division like this. So how many times does 3 base 5 go into 4 base 5? Does that work? Yeah, that's going to work. It's going to go in there once. So 3 does go into 4. We can say that goes into there once. And if you do that, 1 times 3, that's still 3. So this one, we think of it the same way as we would in base 10, because the numbers weren't big enough to add a new place value. But 4 minus 3, that would be 1 in base 5. That still holds true in base 5. Carry down the 2, just like you would doing normal long division. Okay, this is where it starts to get a little tricky. So 3 base 5 goes into 12 base 5 how many times? We need to look over here at our list of multiples. What is the biggest product that's less than what you see here? Less than or equal to. If you say it's 11 in a sense base 5 or 1, 1 base 5, that's the correct one. So we look at this. How many multiples, or how much do I multiply 3 base 5 by to get 11 base 5? I would say 2. So this would become a 2. And then 2 times the 3 isn't 6, it's this right here. We've adjusted the 6 into base 5. So the 6 becomes an 11 in a sense base 5. So we have 2 times 3 in base 5 is a 1 and a 1. Subtract 2 minus 1, you have 1. This becomes a 0. Carry down the 3 here. Let me put in some yellow lines just to make things easier to follow. Please do the same. Please put some light lines in yours at least, just to make sure that it's easy to follow as you go work your way down. Okay, so this, carry this down, carry this down. Keep things straight here. Alrighty, so it's good to go now. 13 in a sense, 1, 3. What's the biggest number, biggest product that goes into there? It's this again. So I didn't make it up the way to make it all the way to the 14. I just have a 13. So this is going to be another 2 going into there. 2 times the 3 becomes 11 in base 5. So I subtract 11. I'm left with a 2. This becomes nothing. So I carry down 2 and 3. 3, I need to add something else to that. So I'm going to carry this 0 down, bring that down here, and I get that, what I see there. Let's make a little note. This red stuff kind of connects with the red stuff over here, so I'm going to put this in red as well. So this one and this one, I feel like you might forget this, so let's definitely write this down. Like, why did we do what we did here? So this was, for both of these, 3 base 5 times 2 base 5 is equal to 11 base 5. This was the largest product. Product is just multiplication, so the largest product less than, I'll say these. So it's the largest product less than these. If one of these was a 14 or a 15 or a 16, we would have used this one instead. I would have put a 3 up here and did 3 times 3 being 14 down here, subtracting 14. If this was a 14 or a 15 or 16, all the way up to 21. If it was a 22, then I would have used a 4 instead here. Did 4 times 3 becomes 22 in base 5, and I would have written 22 there instead. So a little tricky here. You got to look at this list of multiples and figure out what's the biggest, the largest product that's less than what you see there. If you do that, you're good to go. So I'm looking for now, same thing here, same sort of thing. What's the largest product over in this list of numbers that's less than what I see here? If you say 22, that's too high. If you say 11, that's too low. 14 is the largest one that's less than what I see there. So it's going to be 3 times 3 up here. This will become a 3. 3 times 3 is 14. And so now I get this. Now this is a case where I have to go back to my subtraction ideas, that notion. I have to borrow here. I'm going to do my borrowing here, so I'll put a 1 here, and I'll put a 1 here. You're doing so good, Mr. Wagner, so good. All the way to the end, right to there. What did I do wrong? I don't understand what I did wrong. What did I do wrong? Oh, this is base 5, and I just carried 10 over there. That I'm not allowed to do that. Hold on a second. So I borrowed 5 from this place, I have to only add 5 over here. Okay, so now this is good to go. This will become a 1, and this will be a 0. So what's this going to be? I have, my final answer would be this. 1, 2, 2, 3, base 5, with a remainder of 1 base 5. Now with these ones, we are definitely going to check our answers. There was a lot going on here. Let's make one more note here with the 20. So with the 20, and we won't do this with the next one, but I will do this one here. We won't write the whole note with the next one. So 3 base 5 times 3 base 5, that was 14 base 5. This one was the largest product less than this. Largest product less than this one, so less than this. If this would have been something less than 14 base 5, less than 14 here, then I would have done the 2 instead of the 3 like I did there. Or even less. If it was less than 11, then I would have done the next step lower. Okay, so let's take a look at this, and let's check our answer here. So with division and subtraction, it's pretty easy to check our answer. Let's do this in green. Hopefully it will be good to go here. Let me just keep the same format as what I had back here with my subtraction. So to check, I'll keep it like that. Okay, so the same format. What are those? I still have no idea what's going on in those pictures. So let's write our check down here. So this one, let's put our check here. What am I going to check? How can I check something like this? This 1, 2, 2, 3 with a remainder of 1. Both of those things in base 5. So what do I need to do? Just like if I were doing long division with base 10, it's the same sort of thing. I just need to check and see that the divisor times the quotient plus the remainder equals what I started with down here, the dividend. So this one, I should check this first. So 1, 2, 2, 3, multiply that by 3, and both these things are in base 5, so we'll put a little 5 here and here. And let's see what I got. So I'm going to make some yellow lines again. I'm going to do some thinking in base 10, and I'm going to convert, in this case, back to base 5. So thinking in base 10 down here. What is 3 times 3? So some extra multiplication practice within the context of this division problem as we check. 3 times 3 would be 9. 9 is not allowed in base 5. I know that 9, though, is, using my green here, is 1 with a remainder of 4. So that goes right there, 1 and a 4. What's 2 times 3 plus 1? What is that? 2 times 3 plus the 1 would be a 7. How many whole 5s go into 7? That would be 1 with a remainder of 2. Same sort of thing here, same number here, so I've got another 7 right here, and I've got another 1 with a remainder of 2, and then 1 times 3 plus 1 will give me 4. How many whole 5s do I have in 4? I don't have any whole 5s, but my remainder would be a 4. So I have 4, 2, 2, 4 is my first part, and this is base 5. So now I take this 4, 2, 2, 4, base 5, and I must have done something wrong, because 4, 2, 2, 4 plus 1, that can't equal 4, 2, 3, 0, can it? Let's check it out. Plus 1, remember this is base 5 though, so what's going to happen here? Let's draw in our yellow lines here, and let's see what we got going on here. So this, carry this down. Good addition review now from the first part of this lesson. So this is still thinking in base 10. Use your different color for base 10 throughout. And so this becomes, well, in base 5, or in base, in base 10, this would be a 5 But remember, in base 5, you can't write 5. So how many whole groups of 5 do you have in base? Or with a 5, you have one whole group of 5 with, with none left over. So I have a 0 here and a 1 here. Now this is starting to make sense to me. So 1 plus 2 is 3, and then that will be allowed. That's 3 is allowed right there, and that's going to be a 2, and that's going to be 4. None of those are going to change, and so over here we can put our final check answer, 4230 in base 5. Does that work? Does that check out? Is that what we started with here? It sure is. So let's put a couple extra things in here just so you remember, you know where these numbers came from. So this number right here, this was the quotient. This was the quotient. The part up here, my final answer in a sense. Just missing the remainder part though. This is my quotient. This was my divisor. And then right here was my remainder. When we check to make sure that that was all equal to what's right here, the dividend. Okay, so quite a problem there, but hopefully that all made sense. If you take it step by step and just work through the process, you've got it there. And then a lot of this was just the check to make sure that it checked out. So it does check out. We're doing one more example with division. What? Column. Oh my gosh.
That's what you get for doing bad things to columns.
Oh my gosh. Yes, that's me. Thank you, Gollum, for putting that in there. Thank you. I thought I was going to have a nice calm lesson here, but that was, I guess you heard what I was saying before that. I was talking about putting my spelling bee champion picture in here. I don't think you need to see that. Nope. So, 5th grade spelling bee. What a look at those lovely glasses that I had with the insanely thick rims. Yeah, let's put that away. Okay. Let's do one more example here. Hopefully I can still think. Yeah, anyway, let's work this out. Okay, so I got black, and I've got a 4, a 1, an E, and a 3. Yes, we're going to do base 12 here. So we're going to practice one with base 12 with long division. And we're going to divide that by 5 base 12. So just like before, I need to start off by listing my multiples of this part here, of my divisor right there. So what are the multiples of 5 base 12? And over here, same sort of idea as before. I'm going to put my base 10 ideas or base 10 concepts. Use that different color. Whenever I use orange in this whole lesson, I want to see you using your different color that you've chosen. So what do I have here? How many different things do I have? I'm going to have to write kind of small with this one. So I will add an extra line here. So I'm going to write a little bit smaller as I do this. So I have 5 base 12 times 0 I don't need to consider, but 1 base 12 would be just 5 base 12. Let me write all these things down first. So we'll just write down the list of what we got here. 5 times 2, 5 times 3. This is going to go all the way up to this time 5 times 11 because I have 12 different digits to do. I don't need to do the 0, but I need to do the rest. So 5 base 12 times 4 base 12. 5 base 12 times 5 base 12. And just keep writing them. 6, 7, 9. How do we write 10 again? We write a t, so it times t for 10 base 12, and then 5 base 12 times e for 11. What does all this stuff equal? And I'm trying to do what I think is a harder one with you here, so that when you get to problems that aren't quite this big, don't deal with 12 when you're doing dividing stuff, that it doesn't seem quite as hard. So I'm trying to go through what I think is a more challenging one, and so hopefully that'll help you. I'll break it down nice and slow, step by step for you though. So 5 times 2 is 10, and let's just keep going through our list here, and then I'll convert to base 5 all at once. So this will be 15, this will be 20, 25, 30, keep going up by 5 each time, 35, 40, 45, 50, and 55. Okay. And so what does this become? 10 is allowed in base 12, but we would just write a t instead of 10, so t base 12. 15, 10, or 12 goes into 15 one whole time with 3 left over, one remainder of 3, so you'd have 1 3, 13 in a sense base 12. 20, how many times does 12 go into that? You have 1 whole time with 8 left over, so 18 base 12 you could say. 25, how many times, whole times does that go? It's 12 go into there, it's 2 whole times with 1 left over. Into 30, it's 2 whole times with 6 left over. Into 35, it's 2 whole times, that'd be 2 times 12 would be 24, you'd have 11 left over, so 2e base 12. Goes into 43 whole times with 4 left over, it's 36 plus 4. Goes into 45 3 whole times with 9 left over, 36 plus 9. Goes into 50 4 whole times with 2 left over, 48 plus 2. And it goes into 55 4 whole times with 7 left over. That is 48 plus 7 right there. So this becomes my most important list of numbers from what I wrote down over here. It's this right here. These are all my multiples of 5 base 12 up to the final possible multiple, up to the e, up to the 11. So now, just like before, we take this list, we see what the largest product less than these is from what I have here, or here, or here, and so on, and I go from there. So what's the largest thing that I have here to start? There we go. Does 5 go into 4 base 12? No. Does 5 go into 41 base 12? Yes, it does, but how much? So look at this list here, and it looks like here it is. This is the highest one that still totally goes into that. So what do I put up here? Well, 39, I would have to put a 9 above this right here. So a 9 goes here. 9 times 5 is 45 for us normally, but in base 12 it's 39, we would say. So 3, 9. We subtract that. What are we left over with? You may be tempted to say 2. Careful, 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 careful. I almost did that right here too. Be careful when you're subtracting. You gotta borrow the right things, okay? You gotta borrow. Here in this case, we gotta borrow 12 from here. So this is gonna become a 3. And I borrowed 12, so this becomes 12 plus 1, 13. So this right here, 13 minus 9, now I can say that's 4. And I've got right here, 3 minus 3, that'll become a 0. So I will, in red, I will still do with this one, just the kind of abbreviated form of this. Where did this 39 come from? Why did I use that? Because I did 5 base 12 times the 9 base 12 was equal to 39 base 12. That's why I chose to use that, or that's why the 9 was put there. 9 times 5 became the 39 in base 12. Let's put some yellow columns in here to make sure that I keep things lined up and easy to read there. So this, I'll bring that down like that. I'll bring this down and this down right here. Okay, that should come in handy as I continue to go farther down this list here. Okay, so let's carry down now my E. Use the black for that. There we go. carry down my E. The E is standing for the 11, but I look here, look at my list, 4E, what's the biggest one that goes into there? Well, I can go all the way up to here. 4E is basically the last one I would have before this would change and become another digit over here. So 4E I can divide by, or I have 5 times E, 5 to the base 12. If I do that, E times the 5 will give me 47. So underneath here, I can put a 47. That was the largest possible product that was still less than what I saw here. So I'm going to subtract 47 from this. Remember, this is just 11, so 11 minus 7, that's allowed. That's a 4 in base 12. This will become a 0, so I don't need to write that. So where did this come from? Again, why did I do what I did there? This 4E, I used what I did because I looked at my list over here and it was 5 base 12 times the E base 12. That's where this E came from, was equal to 47 base 12, which was less than what I saw there, because this 7 is less than this being an 11 right there. Okay, so we've just got one more thing to think of here. We carry down now the 3, and what's the biggest one less than that in this case? Well, 4, 3, 4, 2 would be less than that. So what's going to go here? I would have to do 5 times the T to get, I see there. So T goes here. T times the 5 in base 12 becomes a 42. So let's subtract 42. I'm left over with 1. And so this, I'm going to circle this, and let's say, or let's look over here again and see that it was 5 base 12 times T base 12. That's why I chose what I did there. That was the largest product that was less than what I saw there. So this was a 42 base 12. That's where that choice came from. Okay, and so from there, I have 1 left over, and that's all I have here. So this would become, this is this base 12, final answer, with a remainder of 1 base 12. Okay, so that is that right there. And was thinking about just saying we won't check it, but I think it's just too valuable, too important not to check this one here. So let's check it down here. I'm going to leave myself a little space. This one will actually check pretty quickly, I think. So let's work on not that yet. There we go. And let's check it in some space down here. So the check, I need to do the same sort of idea as I did here. So I need to take this number times this number, my quotient times the divisor, and then after that add the remainder to that to see if it checks. So I'll take my quotient and that times my divisor, so I'm going to say 9E T, that base 12, times the 5 base 12. I'll put in my yellow columns. I'm thinking about stuff in base 10. Alright, this will bring down here. This will bring down here. And I'm going to do some stuff in orange here. So this is my base 10 stuff. Use a different color here when we're doing the check for the base 10 things. T times 5, that's 10 times 5, which is going to be 50. And so what's 50 in base 12? How many whole 12s go into 50? There would be 4 whole 12s. 4 whole 12s. So 4 would go up here with a remainder of 2. 4 times 12 is 48. There would be 2 left over right there. Now what's E? 11 times 5. That's 55 plus the 4 would be a 59. So down here, I'm going to put a 59. How many whole 12s go into 59? Well, that would be 4. And you'd have 11 left over. So I would put a 4 here and an E here. And then finally 9 times 5 is 45, plus 4 is 49. So down here I have a 49. How many whole 12s go into 49? You say 4 again. You're correct, and you have 1 left over. So you'd have 4 with a remainder of 1. This is that base 12. So now I take this number and I will add the remainder to that to see that it actually gave me what I started with that dividend. So 4, 1, e 2 base 12 plus 1, it's my remainder again, so 1 base 12, and this one being base 12, I can definitely add those together. I just get a 3, and then the e just comes down as e, and the 1 is a 1, and the 4 as a 4. So this checks. That is my dividend. That's what I started with underneath the divided by symbol right there. So this checks out, and that is good to go. So that's quite a bit there. Hopefully that made sense, though. I tried to, as best I could, to break that down in as simple of terms as possible. I think this idea of thinking of it in base 10 is way easier than thinking of trying to do these addition and multiplication tables that they have in the book. But if you like that idea, what they have in the book, you can use that. And yes, that was me. That was my 5th grade spelling bee championship picture. Congratulations. Why don't I just make that a little bigger to make it that a little more embarrassing. Okay, beautiful. Thanks. Hope you understood the lesson. Let me know if you have any questions in the class. We will definitely be practicing through some extra problems with these. Have a good day, everybody.